Hey kiddos, we're moving on to number 17, angles in triangles. Haha, get it? Triangles, and we're talking about angles in triangles, and angles is in triangles. Sorry, I know. Too nerdy, too cheesy. Smile. All right, so a triangle is a polygon that has, yes, you guessed it, three sides. It can be classified by its sides and by its angles. So it basically has two names. So think of it as first name, last name. Wait, sorry. First name, middle name, because its last name is triangle. Okay, so let's classify triangles by sides. First thing that we have is called a scalene triangle. And a scalene triangle would look something like this. And what's significant about it is that no sides are congruent. They're all absolutely different values. That's 3, that's 4, that's 7. Okay, all different sides. Then we move on to the isosceles. Notice what I like to help me remember it by is it's got the two S's right there. So it makes me think or remember that two sides are congruent. So this is what your isosceles triangle would look like. Okay, having two sides that are congruent. And finally, a very, very, very special triangle called the equilateral triangle. It's special because all three sides are the same. Now, sames are the same. It is also technically considered an isosceles because it has at least two congruent sides, but we like to refer to this one as equilateral because it's super special. There's also something very special about its angles, which you'll see in a second. So now we classify triangles by their angles. So first we have an acute triangle. So it has three acute angles. Remember, acute is all measurements are less than 90 degrees. Okay. Then you have the most popular right triangle. And of course, it's always right. Haha. And in order for it to be a right triangle, it has to have at least one right angle. All right. Now the obtuse. Obtuse triangles, very important, have one obtuse angle. That's it. So if there's one obtuse angle, then it's an obtuse triangle. Okay, remember obtuse angles are angles that are bigger than 90 degrees but less than 180. And the very last type of triangle that you have is in, of course, if there's an equilateral, there's got to be an equal angular triangle, which means that all of the three angles on the inside are congruent. Now, here's a little fun fact. The measurements of the triangle, if you add all three of them up, are going to actually add up to 180. I know, crazy. Favorite number. 180. So therefore, that would mean that each one of these degrees measures will forever and always be for an equilateral, equal angular triangle, be 60 degrees. Never ever is going to change. Always true. So we have interior angles, which are angles that we refer to that are located inside of a triangle, dot, 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 okay? But then we also have angles that are called exterior angles. They're basically if we have extensions to the sides of a triangle, as you can see here with these arrows, the exterior angles are the angles that will be located on the outside there. Notice they create supplementary angles or linear pairs here, okay? So example 1, classifying triangles by sides and by angles. Using a ruler, draw and label each triangle if it's possible. Pause and draw away. All right, so hopefully you actually did pause it and you probably did the first one. Okay, that was pretty easy. And you probably did the second one. And then you got here and you said, I don't know about that. So you skipped it and then you did the last one. Okay, so probably everyone's got a probably nice little blank right here. So in obtuse isosceles, notice I have one obtuse angle, two sides that are in fact congruent. Okay. In acute scalene, acute meaning that all three of these angles are less than 90 degrees and all three of my sides are different, scalene. then an equal angular isosceles is possible because equilateral is considered isosceles. So technically, this side would also be the same as all the other two sides. Now, here you probably got stuck. Equilateral right triangle. If you're paying attention before, a right triangle has a 90-degree, and I've already mentioned to you guys that if something is equilateral or equal angular, all of their measures are the same, meaning they're all going to be 60 degrees. So this example is actually not possible. Triangle sum theorem. Kind of already hit on this. The sum of the measures of the interior angles, so the inside angles, all three angles on the inside, is going to be added up to 180 degrees. Pretty easy to remember, I hope. So let's solve for x. So essentially, we are saying that we have these three angles, and they're on the inside of a triangle. So all we have to do is add them up and make them equal to 180 degrees, because that's what triangle sum theorem states. So I'm going to combine like terms. So 1x plus 3x plus 1x, that's that's 5x plus 40 equals 180. We're solving for x here because that's what the question's asking for. So subtract 40 to both sides. 5x equals 140. Last step is to divide by 5. Oh, and I'm feeling so alive. And don't hate on my rhyme. Oh my. And that's going to give you a 28 for your x value. Now, remember, if I really wanted to, we can go back in here and plug it in to figure out all the actual answers. But they just asked for x, so we'll stop there. All right, classifying the side. Which side is the shortest? Now, there's going to be a relationship. The smallest angle, which is 50 degrees in this picture, will be across from the shortest side. So that would mean that we would infer that the biggest angle, 70 degrees, is going to be across from the longest side. So the side that's the shortest is segment CA, and the side that is the longest is segment BA. So this triangle, based on those degree measures, all three angles are less than 90 degrees, which makes it acute. And if all three angles are different, then that means all three sides are different. So this is an acute scalene triangle. First name, middle name, last name. Word. Example 3. Which side is the shortest? Which side is the longest? Then give the full name. Now, what's going to help us here is if we figure out what this is. Now, remember triangle sum theorem. The insides of the triangle add up to 180. So I'm going to do 180 minus 40 minus 25. That leaves us with this being 115 degrees. So, shortest side, where's the smallest angle? Ah, eureka, right here. Across from it is this side, and you cannot answer this question unless you got some letters. So there you go, ABC. So this is triangle ABC, and we're going to be learning our 1, 2, 3s. So our shortest side is AC. That's short because it's across the smallest angle. The biggest angle was this one that we found, that 115. So therefore, that is going to be our longest side, which is AB. So the name is, now I notice these two angles are acute, but this is 115, which makes it obtuse. So obtuse. Now all three numbers are different, so therefore it's still going to be then scalene triangle. that is that triangle's name. Next one. Ooh, throw a curveball at us. This time they give us the sides. So let's see, which angle is the smallest? Well, where's the smallest side? There's the smallest side, and across from the smallest side, guess what is going to be our smallest angle? So angle B is going to be the smallest. Now, for the which angle is the largest? Well, where's the longest side? 10. Across from the longest side, Eureka, we will find the largest angle, angle C. Now, for this triangle's name, now, we're going off of what the picture looks like here because we don't really have any number values for these angles. And based on them, they all look cute, small, cute. And because all sides are different numbers, I know that they're also scalene. So this is a cute scalene triangle. Next example, the measure of one acute angle of a right triangle. See, I have to always draw pictures. And they already gave me my first clue. And they said that it is a right triangle, which means that is automatically 90 degrees. Okay? So the measure of one acute angle of a right triangle is 1.5 times the measure of the other acute angle. Find the measure of each acute angle, draw and label your triangle. So notice I've already helped you. Here's angle 1, here's angle 2. Think, think, think. 1.5 times the measure of the other. I think y'all can handle this. All right, triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So, remember, the longest side of a right triangle is always the hypotenuse. So essentially what they're saying is, if you take the sum of two sides, the smallest two sides, okay, so if you take the smallest two sides, which in this case would be BC and AB, and you add them together, their measurement should be bigger than the third side, okay? So, let's see this in action. So, determine whether the following can form a triangle. So, again, we're going to focus in on the two smallest sides. So, 2 plus 4. And we have to want that to be greater than the third side, which is 5. So 2 plus 4 is 6. Is 6 greater than 5? Why, yes, indeed it is. So yes, that is in fact then a triangle. Now let's look here. We have 8 and 6 is the smallest, so I'm going to add those. 8 plus 6, and remember we want that to be greater than the third side, which is 14. 8 plus 6 is 14. 14 is greater than 14. No, I don't think so. So this would actually not be a triangle. You cannot have a triangle with the side measurements of 8, 14, and 6. Not happening. All right, so a triangle has one side of length 14 and another side of length 9. Describe the possible lengths of the third side. So the first question is, well, what's the smallest possible number that we can get here? Now remember, we're looking at blank plus 9 has to be greater than 14. So what number is going to potentially get us that we can add to 9 that's going to make this a true statement? Well, if you say 5, let's see, 5 plus 9 is, no, that's exactly 14, and we can't have that. So we'd have to go 1 up, and let's try 6. 6 plus 9 is 15, and 15 is greater than 14. So the smallest possible answer would be 6. Now let's think about the largest possible. So let's say we actually have 14 plus 9. Those are the two smallest sides, and they have to be greater than whatever this number is. Well, Well, we would just simply add 14 plus 9, and we would discover that that's going to be 23. So 23 has to be greater than some number. So the closest answer we would get would be 22 to make this statement true. 23 is greater than 22. So the largest possible answer that we could have is 22. So the answer is our range of choices, okay, would be from 6 is less than x, which is less than 22. A triangle has one side length of 6 and another side length of 15. So kind of the same situation as before. If it helps, draw a picture. Okay, 6, 15, that's a short side. Okay, we know there's going to be two situations. All right, 6, 15, and then the longest side. Okay, that's kind of how you have to think of it when you work these problems out. All right, so for the short side, we have 6 plus some value is going to be greater than 15 because I'm using triangle inequality theorem there. Okay, so let's see. 6 plus 6, nope, that's not going to work. 6 plus 8, nope. 6 plus 10, eureka. 6 plus 10 is 16, and 16 is in fact greater than 15. So the smallest number we can get is 10. Now let's look for the longest. So that means we have 6 plus 15 is greater than some value. 6 plus 15 is 21. So 21 is going to be greater than, 20. So our answer is 10 is less than x, which is less than 20. That would be the range of possible answers that we could use that would actually make these triangles work. Exterior angle theorem states the measure of an exterior angle. So I've shown you guys this picture before. It's the angle right outside the triangle, okay, is equal to the sum of the measures of the two non-adjacent interior angles. Non-adjacent means not next to this, which would mean it's angle B and angle A are the two non-adjacent interior angles to angle 1. Another word that we use for non-adjacent interior angles is remote interior angles. So angle A is the exterior angle, all right? Angle C is called a remote interior angle or non-adjacent, and angle D is also remote interior angle. Very important that you remember this and you memorize that concept, okay? These are remote interiors. This is an exterior. So, first example, the theorem for the exterior angle states that these two angles on the inside, the remote interiors, if they are added up together, they will equal the exterior angle on the outside. So, 11x minus 2 plus 8x plus 4 is equal to 17x plus 10. So this kind of has a formula. The remote interior plus the remote interior is equal to the exterior angle. Okay, pretty easy. So let's combine like terms here. 11x and the 8x combined, the negative 2 and the plus 4 combined. That leaves us with 19x plus 2 equals 17x plus 10. I have variables on both sides, so I'm going to subtract 17x to both sides. I get my x's all together. That leaves me with 2x plus 2 equals 10. We're solving for x here, so we're going to subtract 2 to both sides because we're going to always do the opposite to cancel that out. So you get 2x equals 8. Last step, pretty much always, is divide both sides by the value that's with your variable, and we end up with x equals 4. Okay, now what I want you guys to do is plug it in and give me the measurement of angle 1. That's angle 1. the measurement of angle 2. Here's angle 2. And then the measurement of angle 3, which is this angle here, the outside one. All right? Finding the angle measures. Find the value of x and angle JKM. Now I'm going to label JKM, which is this angle here. Okay? So, hey, this is a, what do you know, remote interior plus remote interior equals the exterior kind of problem here. So, let's solve for x first. So, I'm going to have 70, because that's my first remote interior, plus x, because that's the second remote interior, and they're going to equal my exterior angle, which is 2x minus 5. All right, we got x's on both sides, so I'm going to subtract x. We end up with 70 equals x minus 5. Then to get x by itself, I'm going to add 5 to both sides. And we end up with 75 being equal to x. So our x value is 75. Then to find angle JKM, which is the exterior angle, all I got to do is plug it in to the 2x minus 5. So that's 2 times x minus 5. We got x to be 75. So 2 times 75 is 150 minus 5 would leave us with the answer of 145 degrees. And here's the cool thing is if you take the 70 and the 75 and you add them, they should equal what we just got. So let me double check. 70 plus 75. Yes, sir. 145 degrees. So there's a proof that remote interior plus the remote interior equals the exterior angle. All right, next example you are going to do on your own. So you're looking for the value of x. Then you're going to look for the measurement of angle PQS, which is the exterior angle. And you're going to find the angle of QRS, which is this remote interior angle here. Okay, I wrote out the formula for you, and I've labeled which ones they are, so that should definitely help you. All right, this is a very basic theorem here, the isosceles triangle theorem, and it just simply states that if you have two sides of a triangle that are congruent, which would make it isosceles, then the angles opposite those sides are then also deemed as congruent. So I'd be able to make this marking here at these two angles. So in triangle ABC, because AB is congruent to BC, then so is angle A congruent to angle C. And then you have the converse of that, which states if two angles of a triangle are in fact congruent, then the sides opposite them are also congruent. So if you have triangle ABC and you have the angle C and angle A are congruent, so then AB would be congruent to BC. Real simple, kind of easy thing, hopefully, to remember. Sorry for the lengthiness. Not sorry, but you have to learn it.